Prove that the parallelogram circumscribing a circle is a rhombus. So first we have to begin with a diagram, and I hope you guys remember what is circumscribing. Basically, the quadrilateral is touching the circle as tangents, not cutting, not just covering, touching, right? So let me try drawing a parallelogram. It's going to be a bit difficult. This is the tough part. So somewhere, how much? 1, 2, 3. Okay. So hopefully, hang on, wait. Okay, yeah, from here. It has to work out. No, is it? A bit this side. Okay, almost. Right. Anyways, we can't. It's not a construction topic, so this is good enough. So what I've drawn here is a parallelogram. I try to make the opposite side parallel, and thus it's a parallelogram. Okay. So we'll begin with naming it. We have ABC. T is a parallelogram that is circumscribing the circle. We have to prove that this is a rhombus. So we begin with the properties, that is, the opposite sides are equal, right? And they are parallel. I'm just marking the equal part because that's what we'll use. The point of contact, we'll name them P, Q, R, S, right? So let's begin with describing the picture. Let's consider a circle with center O, a circle with center O. ABCD is a parallelogram circumscribing the circle, right? And what else? We can tell that also that since we're talking about ABCD being the parallelogram, so AB is equal to CD and AD is equal to BC. We'll make use of this, that's why I'm writing, right? Opposite sides of a parallelogram. See, why is that I'm doing this? See, first thing is, how will we prove that? Okay, let me complete this part actually. Let me not jump to that. And what else? We can also tell that let P comma Q comma R comma S be point of contact of tangent AB, BC, DC, and AD, respectively. I think we are pretty much done with the diagram, right? It's important to describe the diagram, okay? Because it's not given, so we need to do that. What is that we have to prove? We have to prove that ABCD is a rhombus. So how will you prove it? See, we need to understand the property of rhombus. Property of rhombus is that it's similar to that of parallelogram. Additionally, we have all the sides being equal to each other. So basically, if I prove that, if adjacent sides are equal, right, then it's a parallelogram. That's it. Sorry, rhombus. Because every other aspect of rhombus is proved because it's given it should be this diagram to be a parallelogram. If I prove that this side AB is equal to BC, if not BC is equal to CD, if not AD is equal to AB, we are done. Okay. Now, how will we do it? So we begin with AP being equal to AS, which is equal to X. The length of, why is it so? Why is AP is equal to AS? I'm calling this as X. Why are they equal? The length of tangents drawn from an external point to a circle are equal. Okay, right? So next is PB is equal to BQ. On a similar reason, B, we'll call this as Y, we'll call this as A, and we'll call this as B. So BP is equal to BQ is equal to Y. CQ is equal to CR is equal to A. TR is equal to TS is equal to B. For the same reason as above, right? You need not mention it, not an issue. So now we'll make use of the fact that opposite sides are equal. So we'll start with as AB is equal to CD, right? X plus Y is equal to A plus B. We'll call this as equation 1. I'm just writing what is obvious from the diagram because somehow we have to relate the sides now. So we have to do that. Then AD is equal to BC. So we have X plus B is equal to Y plus A. Okay. So next we have somehow we have to get a relationship between the variables. So let's subtract them. Let's see what happens. X plus Y being equal to A plus B. Then X plus B is equal to plus Y plus A. So this will become minus, 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 minus. This 2 will get cancelled. Then plus A minus A will get cancelled, and Y minus B is equal to B minus Y. If I transpose B and Y here and there, I'll get 2Y is equal to 2B. So divide by 2, we have Y is equal to B. Now, how will this help me? See, Y is equal to, where is it? Y is equal to B. Since Y is equal to B, I can tell that AB is equal to AD. We are done. We just prove that adjacent sides are equal, so it becomes all the sides are equal, and so it's a rhombus. This implies X plus Y is equal to X plus B. Is it not? This implies AB is equal to AD. Thus, all the sides are equal. Hence, ABCD is a rhombus, hence root. Right? Makes sense? Okay, all we had to do is just prove that one of these variables are equal to something else, which they are. It's very clear that Y is equal to B, right? If not, X is equal to A. Anyways, any one of this would have helped. I got one. That's good enough, right? So we proved that adjacent sides are equal, and so by default all the sides are equal, and thus it's a rhombus. Now you can pause and have a look at the answer.